Today we are going to talk about nomenclature of coordination compounds. In this section, we are going to deal with how to write the formulas of mononuclear coordination entity, then how we can name the mononuclear coordination compounds. First of all, we will deal with how to write the formulas of mononuclear coordination entities. How to write the formula of mononuclear coordination entity. First point, the central atom is listed first. The main central metal atom is listed first. Second point, ligands are listed in alphabetical order. We will be considering what are the different ligands in it, and they are ordered or arranged according to alphabetical order. Polydentate ligands are also listed alphabetically. In the case of abbreviated ligand, first letter of the abbreviation is used to determine the position of ligand in alphabetical order. Ethylene diamine, we are representing it as En. So first letter of the abbreviation is taken for arranging in alphabetical order. Next point, formula of the entire coordination entity is enclosed in a square bracket. We will put everything in a square bracket. If the ligands are polyatomic, we will put it in brackets. Ligands abbreviations is also enclosed in brackets. Next point, there is no space between ligand and the metal within the coordination sphere. Next point is, charge is indicated outside the square bracket as the right superscript with the number before the example. In the case of COCN6 3-, you can see first of all we written cobalt, then CN6 cyanide, only one ligand in this case, and it is CN6 6 times. Then we will put a bracket for that CN before writing the number 6. Then we will be putting a square bracket. Then we will write the charge number before the sign. Charge of the cation is balanced by the charge of the anion. If both cation and anion is there, charge of the cation is balanced by the charge of the anion. Another example is PT NH3 twice Cl NO2. Here 3 ligands are there. First of all, we written the central metal atom. Then, according to the alphabetical order, we arranged the ligands. 3 different ligands are amine, chlorido, and nitrito-N. So, first of all, we written amine, then chlorido, then nitrito-N. Another example is K3Cr C2O4 thrice. Here, both anion and cation is present. First of all, we written the positive part or cation part. Then we written the negative part or anion part. The formula is K3Cr thrice. Why? The charge of the complex Cr thrice is 3-. When it combine with K plus, it become K3Cr thrice. Another example, CO NH3 4 times H2O Cl. Outside the bracket Cl2. The cationic part is the complex and anion is Cl. Cationic part is CO, NH3 4 time, H2O, Cl 2 plus. And anionic part is Cl minus. Nomenclature of coordination compounds. Second part, naming of monocoordination compounds. Order of naming ion in ionic complexes. How we can name in ionic complexes. First point is cation or positively charged name is written first, then the anion or negative part. When we are writing the formulas, example sodium chloride, we will be writing the positive part first, then the negative part. While naming, we will be giving name to the positive part, then the negative part. Similarly, in this case also, the positively charged part is named first, then the negatively charged part or anionic part. Example, in the case of K4FeCN6, it is having two parts. Cationic part is K plus and anionic part is FeCN6 4 minus. So while naming, we will talk about the potassium first. Potassium, we will call the name of that metal first, that is potassium. Then we will be naming the complex, that is we are going to learn about it in the coming session. So first of all, we want to give the name of the cationic part or positively charged ionic part. Another example, AgNH3 twice Cl. It is also having two parts. Cationic part is AgNH3 twice plus and anionic part is Cl minus. So while giving the name, diammine silver 1 chloride, we given the name of cationic part first, then only we are talking about the anionic part. Another example, Na3CO NO2 6 times. Here the cationic part is Na plus and anionic part is CONO2 6 3 times. So while naming, we will start with sodium. Now the next one, CO NH3 6 times Cl3. The cationic part is CONH3 6 times 3 plus, anion is Cl minus. So first of all, we will name the complex, then the counter ion. Now, in non-ionic complexes, that is the neutral complexes, it is having a single one-word name. Example, in the case of NiCO 4 times, the name is tetracarbonyl nickel 0. It is not having anion or cation separately, it is having a single thing. So the name is a single one, a one-word name. Another example, PT NH3 twice Cl4, diammine tetrachloroplatinum 4. One word name. Now the second point, naming the coordination sphere. Ligands are named first, then the central metal ion. First of all, we will be naming the ligand, then only we will give the name of the central metal ion. When we are giving the name of ligands, what are the things that we want to take care? Name of negative ligands will end with O. Name of positive ligands will end in EM. Neutral ligands are normally named as such except aqua for water, amine for NH3, carbonyl for CO, nitrosyl for NO. Now order of naming the ligands. It is named in the alphabetical order. PT, NH3 4 times, Cl, NO2. So first of all, we will be talking about the first alphabetical orderly, first one of the ligand, that is amine. Then we will talk about chlorido. Then we will talk about nitrito N. Then only we will go to the central metal atom platinum. Numerical prefix to indicate the number of ligands. When we are talking about ligand, we want to prefix how many number of ligands are there. Prefix may be mono, di, tri, tetra, etc. are used for indicating the numbers. In the case of complex ligands like ethylene diamine, triphenylphosphine, etc., we are not able to use again di, tri in front of it. So in this case, we are using another term in order to indicate the number 2, 3, 4, etc. That is bis, tris, tetrakis, etc. Example, NiCl2 PPH3 twice, that is triphenyl phosphine 2 times. The name of that compound is dichlorido bis triphenyl phosphine nickel 2. Now, we are representing the oxidation state of the central metal atom in bracket. That is a compulsory thing. Last point, ending of names. If the complex is anionic, negative part, the name of central metal atom ends in ATE, 8. Example, K4FeCN 6 times. Here the complex part is negative 1, FeCN 6 times. Name of that compound is potassium hexacyanoferrate 2. Iron become ferrate 3. Ferrate 3. For cationic and neutral complexes, name of the metal is given without any characteristic ending. No change will be given. We will just talk about the metal as such. Example, NiCO 4 times. Tetracarbonyl nickel 0. Since it is a neutral ligand, the oxidation state of nickel is 0. Next one, CONH3 6 times Cl3. Hexaamine cobalt 3 chloride. There is no change for the central metal atom. Now, there are some Latin names for complex anions. Cu is called by cuprate, Fe ferrate, Ag argentate, tin stannate, gold orate. So if we are considering all these things, we are able to give the names. We can see some of the examples. Cr, NH3 5 times, H2O thrice Cl3. First of all, we will talk about ligands, then central metal atom. After that, we will talk about the negatively charged ion or counter ion. So ligands are two in this case, NH3 and H2O, amine and aqua. So we want to talk about amine first. triamine, triaqua, chromium 3 chloride. Next example, CO, NH2, CH2, CH2, NH2 thrice, twice, SO4 thrice. Tris, ethylene diamine, cobalt 3 sulfate. Next one, both anionic and cationic parties complex, Ag, NH3 twice, AgCN2 twice. Diamine, silver 1, dicyano argentate 1. When complex part is negative part, we want to give the name of the metal in this way. So, it become argentate 1.